Hi kids. This is quick review on what you need to be able to do with the writing scientific notation. If you want to refer back, there's the writing scientific notation lecture and review on my site. But this is just kind of a quick tutorial on what you should be able to do. In astronomy, it's kind of weird because you've got sometimes numbers that are discussed that are insanely large, where you're talking about distances from star to star or galaxy to galaxy or the size of the observable universe or whatever. And other times you've got numbers that are like insanely small, where you're talking about what's happening at the subatomic level at the core of stars. So you've got these huge numbers and these little numbers. And when you start to see big strings of zeros behind, it can get a little cumbersome to work with, and the chances of making a mistake or leaving off a set of zeros is certainly there. So scientific notation just visually kind of makes that a little easier to work with. So you need to be able to take what I'm calling big numbers, which realistically is just a number more than we'll call 1, and little numbers, which are going to be a decimal, and write them both in the scientific notation. Or if you see scientific notation, you should be able to like convert that out into whatever the number would be. So regardless of what you're doing, the rule's basically always the same. You've got to move the decimal to a spot if we're converting from a number into scientific notation where that number is between 1 and less than 10. So I'll do this first guy for you. So even though these are commas, it's implied, that the decimal is here. And there's only one spot where I can satisfy that first requirement of moving the decimal between 1 and less than 10. And that would be to convert this to 3.6. So I'm writing this in scientific notation, which is always going to have times 10 to the... Now we got to determine what this exponent is. So what do? You got to count how many spots you'd move the decimal over to get the number that it was you were trying to represent. I usually draw little ditches here. I mean, if you don't want to do that, that's fine, but I just feel like it minimizes my chance of making a boo-boo. So let's count them out. 1, 2, 3, 4, 5, 6, 7. So if I got 3.6 times 10 to the 7th, it's the equivalent of 36 million. So say you got a number that you have to write out what it actually is. Or if I give you something in scientific notation, 1.23. This is how I do it. If you want to just move it in your head, like some kids will look at this and they're like, cool, I move this over 2, I'm going to have 5 more zeros and they're done with it. If you want to kind of go the slow and steady, also fine. You can draw these little ditches or troughs and then fill them in with zeros if you move this 7 places to the right. 1, 2, 3, 4, 5, 6, 7. Fill these guys in with zeros. If you want to go back and put in your commas, that's fine. So it looks like I got 12,300,000, which is the equivalent of 1.23 times 10 to the 7th. So these little numbers, I'll flip this over on what would have been the back of your practice. The rules are still the same. Some of these guys, I'll admit, probably not something that you would have written out in scientific notation, but we're just kind of trying to get the rules down here. So the first step is you got to move the decimal between 1 and less than 10. But we're dealing with decimals. So like I'd mentioned in class, if you've got a positive exponent, it's going to be a big number. It's going to be a more than 1. If you've got a little number, a less than 1, it's going to be a negative exponent for your number there. So let's see how we'd work this guy out. All right, if I do number 3, decimals over here, the only spot where I can go between 1 and less than 10 is there. So I got 2.3 times 10. Now notice here, I got to move the decimal to the left. It's less than 1. This is going to be one of those cases where I know for sure I've got to have a negative exponent. So let's count out the spots that we'd have to move it to the left. 1, 2, 3, 4, 5. So 2.3 times 10 to the negative 5th is equivalent to our problem. Looking at these guys, last thing you got to be able to do, write them out. Check it out. All negative exponents, right? Right. So that means that we're kicking the decimal to the left. You can kind of do the same thing, just if you start here, you're going to end up kind of crunching it up. And I'll show you what I mean by that. If I got 1.23 times 10 to the negative 7th, I'd go 1.23. I know I got to move this over 7 spots. So some kids will say, great, there's 1, add 6 zeros, done, decimal there. Or if you want to go the slow and steady route, draw your troughs. 1, 2, 3, 4, 5, 6, 7. Decimal, go back, all these little ditches or troughs or divots, whatever you want to refer to them as, fill them in, and bingo, bango, bongo. That's all there is to it. So you should be able to take negative exponents, or the little guys, and see them in scientific notation, write out what it would be, or if you're given a decimal, write it out in scientific notation with the negative exponent, or if you've got the big guys, the more than ones, you should be able to write them in scientific notation or convert the scientific notation into what that number actually represents. As always, if you got questions, feel free to see me in class or shoot me an email. Bye-bye.